Example problem number 1, factoring a cubic polynomial. What is the factored form of 3n cubed minus 12n squared plus 2n minus 8? What you'll find is, if we attempt to factor by grouping, we'll have a much easier time finding a solution. As you've previously seen, upon grouping this polynomial into two binomials, we'll then seek out a greatest common factor in each binomial. So I'll continue work here to the right of the screen. But what I'm going to do right now is to consider 3n cubed minus 12n squared and factor out a greatest common factor. I notice right away that in terms of our coefficients, there's a 3 in common. In terms of our variables, there's an n to the first power, but an even higher power of n in common, 3n squared. So the greatest common factor is 3n squared, and that can be factored out to become, I realize I'm going to run out of room up here, let me move my work down below. And we're back. 3n squared times, well, 3n squared times n will give us 3n cubed, minus 3 times 4 is 12, and n squared, perfect. Plus, greatest common factor of 2n and a minus or a negative 8 looks to be 2. 2 times n minus 4 equals 2n minus 8. Excellent. A quick reference back to our originals. 3n squared times n is 3n cubed. Very good. 3n squared times negative 4 minus 12n squared. 2 times n, 2n, and 2 times negative 4 minus 8. Very good. Good to check your work as you go. Notice now, we have a binomial in common between these two terms. Therefore, we can factor that binomial out. And in factoring it out of both terms, note that to get back to the previous step, we would have to multiply this n minus 4 times 3n squared plus 2. All right, so you can think of this as factoring out that greatest common factor of n minus 4, or you can think of this as I've mentioned it before. It's almost as though we have n minus 4, and that's a thing that you could have, or let's pretend it's something that would fit in your hand. In this case, we have 3n squareds worth of n minus 4s, whatever that is, but 3n squareds of them, and then we're adding 2 more of them, so we can think of that as being 3n squared plus 2 of them. So just another way to kind of wrap your brain around the algebra that's taking place here when we factor out that common binomial, or greatest common factor of n minus 4. And there you see we have our solution. And a chance to show that you have got it. A, what is the factored form of 8t cubed plus 14t squared plus 20t plus 35? And B, a reasoning question, how is the factoring method used in problem 1, the example problem we saw on the previous slide, like the method used in lesson 8-6? And how is it different? And to help you remember, I had to refer back to lesson 8-6 to figure it out myself. To help you remember it all in this one video without having to go back to lesson 8-6, keep in mind that in lesson 8-6 we were splitting apart a middle term in such a way that allowed us to group and factor out greatest common factors. So in that way it's very similar, and I've kind of given you a lot of your answer to part B, but just keep that in mind. It was 8-6 where we were introduced to this idea of separating the middle term to make our trinomial easier to factor. And example problem 2, factoring a polynomial completely. Always keep in mind, when you begin factoring a polynomial, you should seek out and factor out, if you find, a greatest common factor. Here's a good example. 4q to the 4th power minus 8q cubed plus 12q squared minus 24q. Notice we have a great common factor. 4 is a factor of all of those coefficients And q is a factor of all of those variables. So we can factor out a 4q from this entire polynomial. Note then that 4q times q to the third power minus 2q squared, 2q squared, plus 3q minus 6 would get us back to our original polynomial. Let me do a quick check by distributing and thinking about this in my head. 4q times q to the third power is 4q to the fourth power. Distribute the 4q to the minus 2q squared. That would be minus 8q to the third power. Good. 4q times 3q would be 12q squared, a positive 12q squared. And 4q times negative 6 minus 24q. Perfect. So now that that is done and we've factored out the greatest common factor, then we set to work factoring whatever polynomial remains in the parentheses. That's similar to some con videos that are assigned. It's similar to some work we've done in the past when we factor out a greatest common factor. From this left group of terms, focusing on the left one first, of q squared. Q squared times q minus 2 would get us back to this q to the third power minus 2q squared. And then we've got a plus and 3, our greatest common factor. Q minus 2, always a good sign when our binomials match. Great sign, actually. And do not forget that we do still have a 4q kind of hanging out over here on the left-hand side. Probably a good idea to write that first so you don't make the mistake that I almost made, which is to forget about the 4q. It is one of the factors of our polynomial, and it needs to be there in our final solution. Well, we're almost done. Why not just finish this one? Factoring out a q minus 2 from both of these terms will leave us with 4q times q minus 2, you see where that came from, plus, nope, times, undo, times q squared plus 3. All right, let's check against the book solution. Very good. Notice something interesting, and I've noticed something interesting, so I'll share it with you. See, I've been placing the q minus 2 first in our factored form, or the q minus 2 in this case, our common binomial, first in our written solution. The book places that last. The reason I began placing it first was simply because con chooses to do it that way. Notice your textbook chooses to write it the other way. We know that these two answers are equivalent because, again, multiplication is commutative, so it doesn't matter in which order you write the product or the factors that lead to the product. Just beware of that. If you're checking your answer against the book solution or you're working out a multiple choice question and the order seems different, as long as it's simply the order of multiplication, that's all right. And a chance to show that you have got it. What is the factored form of 6h to the fourth power plus 9h cubed plus 12h squared plus 18h? Factor completely. Example problem 3. Finding the dimensions of a rectangular prism. This takes you back to the solve it problem we completed, it was in the first Ed puzzle video with the kind of blue background, the company with boxes A, B, and C. This is very similar. What we have here is the toy shown below is made of several bars that can fold up together to form a rectangular prism or unfold to form a ladder. What expressions can represent the dimensions of the toy when it's folded up? So again, very much like that original problem we saw in this section, we just need to factor the volume polynomial into into exactly 3 factors. So this is a story problem, a problem that does apply to real life anytime you have the volume of a right rectangular prism and you know its volume in terms of a polynomial, you can simply factor it. So that would be our job at this point, to consider the polynomial given to us for volume and then to factor it using the methods that you've learned, most likely seeking out a common factor, a greatest common factor, I see one, and then considering the polynomial left in parentheses and factoring that further. Those resulting factors, there'll be 3 of them, will represent your possible or one possible length, width, and height of the box. And you are certainly welcome to pause and check this out. However, apart from, well, extracting what we need to do, simply factoring the polynomial, from the story problem, this isn't much different from the example problems we've seen previously. So I will not take the time to walk through this problem step by step. Again, if you're interested, you are welcome to. An opportunity to show that you have got it. A rectangular prism has a volume 60x cubed plus 34x squared plus 4x. What expressions can represent the dimensions of the prism? Use factoring. And your lesson check for this section, all on one page.